So this is the 2024 Higher Level Applied Maths Leaving Cert paper question 7. Fiona plays camogie and wishes to improve her accuracy in scoring points. She stands at P, which is 35 meters in front of the goal line, and strikes a slitter with an initial velocity of 20 meters per second at an angle alpha to the horizontal ground. In order to successfully score a point, the slitter must pass over the crossbar, which is 2.5 meters above the ground as shown in the diagram. Derive an expression in terms of alpha for the time taken for the slitter to reach the goal line. We're going to use, first of all anyway, s is equal to ut plus half at squared. So we're going to look at the distance in the x direction. Let's just resolve this angle first of all. You've got an angle of alpha, so we're going to resolve it this way and this way here. This is alpha and our velocity is 20 meters per second. So this here is going to be 20 cos alpha and this is 20 sine alpha. So this is the initial speed in the x direction. So we want the distance in the x direction, which we know is 35, is equal to the initial speed in the x direction, which is 20 cos alpha times t plus half gt squared. G here is just going to be 0. So Sx here is 35 meters. So it's 20 cos alpha times t. So this just becomes 0 because there's no gravitational force in the x direction. So we want an expression for t, so it's just simply going to be t is equal to 35 over 20 cos alpha. Or we can just say t is equal to 7 over 4 cos alpha. Okay, that was part 1. Let's have a look at part 2. So calculate the values of alpha such that the slitter hits the crossbar. If we take flight of the path looking something like this, and let's say the crossbar is here, this is 2.5 meters, this is 35 meters from here to here. So what we're going to do now is look at an equation for distance in the y direction, substitute in the time, and then from that work out the values for alpha. So we're going to look at, again, s is equal to ut plus half at squared. So now we want the distance in the y direction. So that's the initial velocity in the y direction times time. So it's going to be minus a half gt squared. So in this case, because we're looking in the y direction, the force due to gravity is going to apply, and it's going to be in the negative here as well. So let's stick in some values. We're looking for the distance in the y direction to be 2.5 meters. The initial velocity in the y direction, I should say, from part 1 is 20 sine alpha, and then we've got to multiply all that by t, then it's minus a half gt squared. So from this now I'm going to substitute in what I got in part 1 in here, and then we should be able to work out alpha from that. So what we get is 2.5 is equal to 20 sine alpha times t, and remember t was 7 over 4 cos alpha, minus a half g t squared, which again is 7 over 4 cos alpha, and we've got to square that. So let's simplify this first before we do anything with it. So it's 2.5 is equal to, we've got to multiply 20 by 7, so that's 140, divided by 4, that's 35. So what we end up with is 35, and then we've got sine alpha over cos alpha. So when you see sine over cos, you should really think about tan, maybe changing this to tan at some stage. So let's see, we've got minus a half g. Now we've got to square all of this here, so it's going to be, let's see, 7 squared over 16 cos squared alpha. Okay, so let's just simplify this a little bit. We've got 2.5 is equal to 35. I'm going to call this tan alpha. And out here I've got 49 on the top, 49g actually on the top, so it's minus 49g g, and then on the bottom I've got 2 times 16, which is 32, and what's left is this here. It's 1 over cos squared, and in your tables you'll see that that's sec squared, and sec squared then is equal to 1 plus tan squared. So out here I've got 1 plus tan squared alpha. So the next thing I'm going to do is just multiply out that bracket, so it's 2.5 is equal to 35 tan alpha minus 49g over 32 minus 49g over 32 tan squared alpha. Okay, so what I've effectively got here is a quadratic trinomial, so I'm just going to bring everything over to one side. So let's see, we end up with 49g over 32 tan squared alpha minus 35 tan alpha. Now when I bring this over to this side and add it to the 2.5, what I'll end up with is plus, and multiply by g by the way as well, I'll end up with 2801 over 160, and that's equal to 0. So what I've ended up with here really is just a quadratic trinomial. So a is this thing here, b is minus 35, and this is c. So what I need to do is just put all that into the quadratic formula and get my two values for alpha. So let's do that then. So my tan alpha is equal to minus b, so that's 35, plus or minus the square root of b squared, so it's minus 35 squared, minus 4 times a, which is 49g over 32, times c, which is 2801 over 160. And then that's all over twice a, which is 49g over 32. So that's just calculator work. So what you should end up with is tan of alpha equal to, if you take the plus version, here you should end up with tan alpha is equal to 1.605931039 on your calculator. Just do tan inverse of that and you'll get an alpha then equal to 58.08981897 degrees. You'll also get a tan of alpha equal to, when you do the minus version, 0.7264304775, and that'll give you an alpha of 35.99579.782 degrees. Again, you could round that, so maybe 58.09 degrees, and let's say 36 degrees, I guess, 36 degrees. Okay, and that's it for part 2. So this is B part 1. In the stunt cage of a circus, a motorcyclist performs acrobatic stunts in a hollow sphere of diameter 20 meters. The motorcyclist and motorbike labelled M in the diagram have a combined mass of m kilograms. M moves with uniform horizontal circular motion. The line from M to the centre of the sphere makes an angle beta, which is tan inverse 4 over 3 with the downward vertical. A student models the motion of M. In the student's first modelling iteration, friction is ignored. Draw a diagram to show the forces acting on M. So the forces acting on M then are going to be, first of all, its weight, which is mg. You've got the normal reaction along this way, or let's call it OR. So the circle comes down around this way if you like. We can resolve the weight this way in towards the center, down along this way. So this will be beta here as well. So this is mg cos beta, and this would be mg sine beta here. And that's really it. That's all we have to do for part 1. Okay, so this is part 2, calculate the velocity of m. So before we do that, I'm just going to have a look at some force diagrams. So let's take first one. This is m here, this is going to be mg down along here. And we resolved that earlier this way towards the center if you like, and this way here. This is beta, so this here is mg cos beta, this here is mg sine beta. The other force then is going to be acting up along here. That's the normal reaction, we call it OR. So I'm going to resolve that horizontally and vertically. This is beta here again. So out here we will have OR cos beta. Here we'll have OR sine beta. Next thing I'm going to do is have a look at the circular path that the motorcyclist travels. So we've got to find the radius out along here. First thing we'll do is just have a look at this distance here, which we know is 10 meters, because we were told that the diameter of the sphere is 20 meters. Come down along here, and we know that this is beta here. So we know then that this here will have to be 10 sine beta in distance, and this will have to be 10 cos beta in distance. So we're going to use those as well. The last thing I want to just have a quick look at is this right angled triangle here. Let's say beta is here. We're told in the question that tan inverse beta is 4 over 3. So this must be 4, this must be 3, so this must be 5 here. In other words, 4 squared plus 3 squared is equal to x squared, and you'll find that x is just equal to 5. It's a 3, 4, 5 triangle. So now we have the sine, cos and tan of beta if we need them. Okay, so let's start then. What I'm going to do here, in order to find the velocity of m, I'm going to form two equations. I'm going to combine those two equations to find v. The first equation involves looking at the vertical forces, this one and this one here. And the second one involves looking at the centripetal force here. So let's do the first one, which is just going to be OR cos beta, which is this one here, force up. That's equal to the force down, which is mg. That will give me an OR. That'll give me an OR of mg over cos beta. So that'll finally give me an OR then of, we know that cos is 3 over 5, so we just need to flip that upside down and multiply, so that gives me 5 mg over 3. So that's equation number 1 that I'm going to use. Next thing I'm going to do is have a look at the centripetal force equation. So centripetal force is equal to mv squared over OR, and this OR here is the radius, this radius here. So the centripetal force as well is going to be all the forces towards the center of the circle. The forces towards the center of the circle are just this one here, OR sine beta. So that's going to give me OR sine beta is equal to mv squared over OR, which is 10 sine beta, this distance here. Okay, so let's just simplify this a little bit. We can see here that sine of beta is 4 over 5. So we put that in for these two sines. So this is OR times 4 over 5 is equal to mv squared over 10 times 4 over 5. That'll give me, let's see, well, I'll just do the right hand side first. That's mv squared over 5 into 10 is 2, 2 4 is 8. Now all I've got to do is bring that 4 over 5 over and divide. So what I'm going to do is flip it upside down and multiply. That'll give me an OR of, I'm going to multiply, in other words, over on this side by 5 over 4. So I'll end up with 5 mv squared on the top and 4 eighths 32. This is my second equation. So now I have OR equal to this thing, OR equal to this thing, so I'm going to just let those two equal to each other and solve for V. Let's do that down here. So we have 5 mg over 3 is equal to 5 mv squared over 32. Okay, so we can see that on the left and right hand side we have a 5m and a 5m. So that leaves us with g over 3 is equal to v squared over 32. Let's just cross multiply, so you got 32g is equal to 3v squared. That'll give me v squared is equal to 32g over 3. And finally then we have our expression for v, which is the square root of 32. Just do this a little bit neater. Square root of 32g over 3, and this is meters per second. So this is, just stick that in there, meters per second, and that's approximately equal to square root of 32g over 3 is approximately equal to say 10.2241544 and so on. Again, that's meters per second. Okay, and that's it for part B2. Okay, so let's look at part 3. The student's second modelling iteration introduces a coefficient of friction mu. Draw a diagram to show the forces acting on M when it is on the point of slipping downwards. Okay, so again we're going to start with M and we'll draw its weight first. So weight is acting down. So that's mg. That's its weight. And we resolve that this way and this way here. This was beta. So here we have mg cos beta, and here we have mg sine beta. We also had the normal reaction, which was up along this way. We call that OR, and we resolved that horizontally and vertically. We've got beta here, and we said that this was OR cos beta, and this is OR sine beta. So friction is going to act along the line of the tangent to the circle at the point of contact. So it's going to act in the opposite direction up along here. So this would be a tangent. If you imagine the circle coming around here, this is going to be a tangent to the circle. We'll call this friction force. And again, I'm going to resolve this way, horizontally and vertically. So I just need to work out these two here. In other words, what's this angle here going to be? Well, if we look at these two angles here, this is a right angle, because remember this is your tangent to the circle and this is a radius here, if you like, or it's along the radius of the sphere. So that's 90 degrees. So what's this angle here? Well, this angle here is, well, this is 90, this is beta, so these two must be 90 degrees. So this angle here would be 90 minus beta. So really we've got this straight line here, and we have 180 degrees there. So in order to work out this angle here, we would take 180 degrees, we would subtract 90 degrees plus 90 minus beta. We would add those two angles. That will give us 180 degrees minus 90 plus beta. So that gives us 180 minus 180, which is 0, so we just get beta. In other words, this angle here is also beta. So that's handy enough. So this is going to be the frictional force sine beta, and then down here, I'll just do it in a different color just to distinguish it, it's going to be the frictional force cos beta along here. So there are all our forces on M, including the frictional forces, the weight and the normal reaction. So that's it for part 3. Okay, so let's have a look at part 4. M has velocity 7.5 meters per second when it is on the point of slipping downwards. Calculate the value of mu. So what we're going to do here is the same as what we did in part 2, or B2. We're going to look at the forces up and the forces down. We're going to make an equation. We're also going to have a look at the centripetal force. We're going to make an equation. We're going to combine those two equations to work out mu. So it's similar to what we did before, but a little bit trickier, a little bit longer anyway. So let's look at the forces up versus the forces down first of all. So if we look at this one here, we've got friction times sine beta up along this way, we've got OR cos beta up along this way, and then we've got mg acting down this way. So these two added must be equal to this one here. So let's write that out first of all. So forces up equals forces down. So we've got F4, we'll call it, sine beta plus OR cos beta is equal to mg, the force downwards. So you have to remember that friction is mu times OR. Frictional force is just mu times OR, so I'm going to substitute that in. So it's mu OR sine beta plus OR cos beta is equal to mg. So this is my first equation. Let's look at another one then. Let's look at the centripetal force. So the centripetal force again is equal to mv squared over r, and that's equal to all the forces acting towards the center. So in this case we have this one here and we have this one here along the center of the circle, the horizontal circle. So it's going to be r sine beta minus friction cos beta. So let's write those down. So mv squared over r is equal to r sine beta minus our friction times cos beta. So we have mv squared over r. Remember, r was 10 sine beta, so it's going to be 10 times 4 over 5, which is just 8, is equal to r times sine beta again is just 4 over 5, and then we've got minus the friction again, remember, is just mu times r, and we've cos beta, which was 3 over 5. Okay, so that's our second equation. Let's take our two equations. I'll just write them down one under the other. So we take equation 1, we have 4/5, which is sine beta times mu r, plus we need cos beta, which was 3/5 r, is equal to mg. So that's just this equation here with sine and cos substituted, 4/5 and 3/5 there. So that's equation 1. Equation 2 then is just this one here, so it's I put in the mu r underneath the mu r, so it's minus 3/5 mu r plus 4/5 r is equal to mv squared over 8. This is equation 2. Okay, so what I need to do is some kind of simultaneous equations here. I'm going to have to do it really by substitution. So I'd like to get rid of the r. So what I'm going to do is I'm going to take equation 1 and I'm just going to take out the r, just factorize out the r. That'll leave me with 4/5 mu plus 3/5 is equal to mg. That'll give me an r of mg over 4/5 mu plus 3/5. What I'm going to do is substitute this into equation 2 here. So that'll give me minus 3/5 mu mg over 4/5 mu plus 3/5. That's the r, plus 4/5 mg over 4/5 mu plus 3/5. All that's equal to mv squared over 8. Okay, so now I have an equation with just mu in it, so I can just solve for mu. So what I'm going to do here is multiply these fractions out. So I'm going to multiply the top by the top, so minus 3 times mu, that's mu over 1 if you like, times mg. That'll leave me with minus 3 mu mg on the top. And then on the bottom I'm multiplying these by 5, so the 5's will cancel and I'll end up with 4 mu plus 3. Over here something similar, just multiply the top by the top, so 4 mg, and then multiply across by 5. The 5's will cancel and I'll just end up with 4 mu plus 3 as well. And on the right hand side I've got mv squared over 8. I'm just going to get rid of these m's. That'll leave me with minus 3 mu g over 4 mu plus 3 plus 4g over 4 mu plus 3 is equal to v squared over 8. Okay, next thing I'm going to do is I'm just going to add these two fractions here if you like. So I'll get 4 mu plus 3 on the bottom, so that'll leave me with minus 3 mu g plus 4g on the top, v squared over 8. Got a fraction equal to a fraction, so I can just cross multiply. So I'll get minus 3/8 24 mu g plus 4/8 32 g is equal to v squared times 4 mu plus 3. Now we were told in the question up here that let's see, the velocity is 7.5 meters per second, so I can substitute that in as well. So let's do that. So we have minus 24 mu g plus 32g is equal to v squared, which is 56.25 times 4 mu plus 3. Okay, next line then. We have minus 24 mu g plus 32g is equal to, I'm just going to multiply out this bracket. That'll leave me with 225 mu here plus 168.75 here. So let's just try and get mu on its own. So we have a mu here and we have a mu here, so I'm going to put those two together. So that's minus 24 mu g minus 225 mu is equal to 168.75 minus 32g. Okay, so next line then, I'm just going to factorize out the mu here, which will leave me with minus 24g minus 225 is equal to, when you do this over here, you'll get minus 144.85. Okay, so almost there. The last thing I've got to do is just divide across by this here. So I'm going to do that up here, come up along this way. So you get a mu is equal to minus 144.85 all divided by 460.2. So just multiply that out and add them, multiply these two out and subtract that, you'll get 460.2. So that'll finally give me a mu then of 0.31475 and so on. That's really my answer there. Okay, so that's really it for this question. Quite a long question, but that's it.